Hi everyone. Thank you for watching my video. This week I'm going to describe how to use Python to conduct a uh, descriptive analysis and predictive analysis. First of all, we need to know our uh, objectives. So first, let's find assessment is here. Oh, should be here. So we need to use the data provided by Professor Addy and then conduct a descriptive analysis and predictive analysis using any statistical tool. So in this case, I will use Python. So first of all, let's get so you need to by using Python, that means you need some necessary packages like pandas, numpy, and matplotlib. So first of all, we get the data from my desktop. I storaged my data here, desktop GPC for B421 and this course. Then you get your data uploaded. By using data head, then you can check the first five row of the data. So of course, if you want to check the bottom five, you can use tail. Then it shows the last five rows. Or maybe you want to see 10 of them, just do like this. Then it shows. If you want to see the first of 10, then you just give a parameter 10, then it will show, okay. From this, we can clearly see, okay, there is some missing values here, but we don't know how many missing values there. We may investigate that later. Then use data.describe. Then you can see, okay, we can get some general information that we can answer the first question was descriptive analysis, like what's the mean, median, average, minimum, and maximum. For example, let's see here, we use credit score as an example. There are 7,500 rows in this data set, and the average credit score is 1,063. And then let's see the maximum credit score shows here, and the minimum credit score is 585. So here is some basic information you can get those you can use for like we will know the home ownership, uh numbers of open accounts, years of credit history. In this one, we can see, okay, the average years of history is 18 years. So that means this data tracked a long period of users' client back information. So then, by applying this, data is now dot sum, then we can see, okay, how many missing values. From here, we can see the annual income has 1,556 missing values. The year of in current job has 370 missing values. And if you divide by the data shape, then we will get a percentage. That means 20% of annual income values are missing here. 4% of years in current job is missing. Another one is 54% of the month since last delinquent value are missing. Then we applied data information. By this, we can get all of those columns and rows and what's their data tag. Giving those basic information, then we move to the assessments, which ask us, okay, to give some value for insight about descriptive analysis. So for example, I use annual income to be a sample here. It By using Python, we can see the minimum annual income in this data set is 16,000 164,597. The maximum figure shows here, and the average annual income is here 1.3 billion. And also, is this by running this code, you will get the standard deviation for the annual income. Here is another example. I use the home ownership to see the percentage of, because we have four unique values here, 1, 2, 3, 4. But we haven't we didn't, we haven't have the description information about this data, so we don't know which number represents which type of home. So I guess it should be detached house, condo, apartment, things like that, but we lack of the information in this case. Uh, here is a here is a historical plot shows the credit score. So you can see the majority of clients have credit scores less than 1,000, and most of them have a credit score between 500 and 750. And after this, we can apply a correlation to see the correlation shape between different values. From this heat map, you can see the number of credit problems has a high relationship with high correlation with tax linears, and the bankruptcies have a correlation with the number of credit problems. We will investigate those relations in the following analysis, but so far it shows, okay, which area we should put our intention, and we should do more investigation to see, okay, which variable has an impact on another variable. So first, we do the correlation, with simple linear regression between bankruptcies and the number of credit problems. We already see they have a correlation between here, but we want to investigate further about those two variables. So first of all, we do a value count to see, okay, the majority bankruptcies have the value 0, and then we need to fill none. It has 14 missing value in this column, and then we get we get those 14 records, and then by using fill none, we get all those missing values with the value of 0. And then we apply linear regression model from Scalene, set up X as uh, credit problems, Y as bankruptcies. So then using this, you can see this is a linear the scatter plot as a linear model we created for this relationship, and here is the formula we generated from this. In this case, you can see the interceptor is 0.03 and the coefficient is 0.5, which means one more number of credit problems will increase 0.5 of the chance to lead to bankruptcy. And in this one, because we have R squared as 0.5.4, that means this model can explain 53% of the overall data, which you can also see from here. You can see the line from here to here, all the data in this area. That means it fit with this model, but we also see some outliers. Those may not fit with this. This explained that uh, X. This explains that why this model can only explain 53.4% of the overall data set. And also here we can see this data set is scurred. Oh, it's scurred to the left side, and the kurtosis is 38.995. After this, I applied another multilinear regressions. In this one, I add tax linears, month stat, current credit balance, current loan amount, year of credit history, home ownership as X, and Y using credit scores. Simply by running this, we get the interceptor and the coefficients here. But we can see by adding all of those variables here, we see a really low R square. That means this model can only explain 0.7 of the whole data set. That means this is not correct. This model is less reliable and we should discuss that. But also you can see because the credit score is high, so we have the intercept as 1147, but those coefficients is relatively small. So that means this model is inappropriate. So we have to do a standardized, we need to normalize our data before we apply this multilinear regression. So in this one, I apply the standard scalar. Then we transfer all the data to standardize the data. And then we run the same code again. Then you will see, okay, this one is more clear. Those like tax linear monthly debt have positive impact on credit scores. But current credit balance and current loan amount, year of credit history have the negative impact on the credit scores. However, I have to highlight that here it's also the R square is really low. So it means those variables actually have a very tiny impact on credit scores. So this model is unreliable. But from here, we can see the current loan amount is highly related to credit score as the p-value is 0.00. So we can investigate these two variables in the future if we need more. We need to see more trend. And that's it. Thank you.